check in. I am back in beautiful, fragrant downtown San Francisco in the Soma neighborhood. Our guest this week, Talha, where are you joining us from?
I'm joining you from Berlin, Germany.
Excellent, excellent. I've heard many, many good things about Berlin over the years. I hear it is a very, very beautiful city.
Yeah, indeed.
Happy New Year, Steve, our good buddy Steve Simpson in the chat. Always good to see you, Steve. Good morning, Norway. Let's take a look on our other services here on LinkedIn Live. We've got 33 of you watching over there. Go ahead and chime in. Tell us where you're coming from. We do love to see it. This episode is going to be a fun one. It's a first in our new series of showing some of the projects that we've featured on OpenCV Community Friday, which we've been doing for the last month and a couple of weeks. If you've got any cool projects you want to see on OpenCV Community Friday, please send those in to us. You can send them to newsletter@opencv.org, or you can fill out the handy form that we've got. I'll post a link to that form a little bit later in the show once we get started proper. Congratulations to Steve for incorporating. That's always a big step, man. Hello, Hamburg, Germany. Hello, Morgan, who's listening from the hate. You can probably hear me if I yell really loud. Hello, Pakistan, the Netherlands, more Pakistan. Hamudu from Sri Lanka. Hello, Sri Lanka. We got Felicia from Kent, Washington. Hello, Felicia. It's not goodbye, Felicia. It's hello, Felicia. We got Diego from Switzerland. We'll get started in just a minute or two here as we wait for everybody to filter in. Hello, Spain. Hello, Josh, all the way from Orlando, Florida. Hello, Bali, Indonesia. Bonjour de Quebec. Yes, indeed. Thank you so much for joining us, folks, on this first episode. I guess Jira from Manchester says hi. Hello, Manchester. Hello, Czech Republic. Hello, Lorik, Southern Germany. Hello, Odessa, Ukraine. Hello, Sumit, India. Sumit from India, rather. Sorry. Hello, Poland. Hello, Turkey. We really appreciate you joining us here on this beautiful Thursday morning. It's about 65 degrees here in San Francisco, California. I hope that the weather is clement wherever you may be. I guess now is as good a time to any to get started.
All right, then I'll share my screen.
Hang on here. I'll do my little intro
Oh.
first. So you can go ahead and
Oh,
kill
sorry.
it. Yeah, no sweat, man. We edit these for a reason. Good morning out there, everyone. Welcome to OpenCV Live, episode 120. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson, if you're nasty. But you, my dear friends here on OpenCV Live, can call me Phil, and I'm here to host the show solo today. Dr. Satya Malik is feeling a little bit under the weather today, so send out your good vibes and well wishes to the doctor. He will hopefully recover quickly and soon and be back with us next week. But until then, you're stuck with me. On this show, we do a couple of things every single episode, the first of which is a special giveaway to you out there in the audience. So please stay tuned, and later in the episode, I will ask a question based on the slides from our guest here, Talha. And the first person to answer that question correctly in the Zoom chat will win the OpenCV course of their choosing. You can go to opencv.org to see what courses are available there. Stay tuned for that. We're also taking questions from you in the audience. So at any time during the show, ask your question using the Zoom Q&A button at the bottom of the screen there, or ask your question in the chat system wherever you're watching. We're live on Twitter, Twitch, YouTube, Facebook, Twitter. I'm never calling it X. It's still Twitter to me, damn it. But having said that, we have an exciting guest today. Tala is a OpenCV community member who was featured in one of the OpenCV Community Friday newsletters. You can subscribe to OpenCV Community Friday on LinkedIn or on the OpenCV website at opencv.org/subscribe. This project was really interesting to me because it's obviously a personal project. It's something that our guest has a lot of personal connection with, but also it uses lasers. And you know how much I love me some lasers. Welcome, Talha. Say hi to the folks out here. Tell them who you are.
Thank you, Phil. Thank you. It's quite special to join OpenCV live weekly this week. Yeah, I will just introduce myself throughout the presentation and tell you about more about the project. So
Great. Take it
I'll
away.
just go ahead and start. Okay. First, I'll share my screen. Can you see it?
Looks great to me.
Okay, perfect. So, yes, today's topic is bringing the party to fruit sorting with OpenCV. And as Phil introduced it, it's quite a dear project of mine. And my close circle, my close connections know that I do these kind of side projects, and this has been something that's ongoing for a long time. And I will tell you more about it. And yeah, let's start. First of all, the reason that we are doing this today is actually the original post that I shared on LinkedIn. So if you're watching offline right now, you can just follow this QR code, go to the original post, and then come back to this presentation where we go deeper into the project and the background of it. But the original thing is there. So the project is about olives, fruit sorting, and I'm originally from Turkey, and uh, I just want to touch upon the topic of olive farming in Turkey, Anatolia, which goes back quite a long time, 6,000, 4,000 BC, and there are actually many varieties of olives being grown in Turkey. Of course, it's not special to Turkey. It's in Greece, Italy, and Spain. All the Mediterranean region is quite well known for olive growing, but it's quite historic fruit also, with its own culture within the cuisine of different countries.
And it's used for
Um, and
many different things in all those different cuisines as well. It's a very versatile crop.
Indeed, indeed, and even like the output, like the byproducts of the production, when you're producing olive oil, for example, the 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 remaining like the solid parts from the olives after the oil has been extracted, for example, it can be used for as a fuel also. It has been used as a fuel in the earlier ages. Yeah, so it's quite a useful product, I would say. And it's quite big also in Turkey. You can see like a 500,000 tons of tabletop olives being produced per year, or 300,000 tons olive oil. And for the US speakers or US people here, I think 1 ton is like 2,000 pounds or something like that. So it's quite a lot. And my farming background, I'm not a farmer. My family is are not my family. My parents are not professional farmers, but we have some like small scale olive gardens from my grandparents, and my parents have been continuing that. It's not their first profession, but they're just continuing growing every year and selling the extra, keeping some for ourselves and selling the extra, uh, so that it's ongoing.
Sounds
And
like a
after the
pretty
project,
interesting side hustle, I would say.
yeah,
A lot of
yeah.
people are doing like gig services and whatnot. I think I prefer farming.
Yeah, and actually, some people, dream about doing this. When they retire, they want to have a garden, they want to grow crops and things like that. So, yeah, they are lucky that they have it already, and it's quite, uh, yeah, it requires effort, of course. It's not an easy thing, but they continue, and I'm so glad that they are doing that. Um, my personal introduction is I did my Bachelor of Science in Mechanical Engineering in Istanbul, Boğaziçi University. And then after that, I did my master's in Eindhoven in the Netherlands. Uh, and there I lived since I think 2013 until the Corona time. And recently I moved to Berlin, Germany. My interests are in obviously robotics and computer vision. But actually, after this point, this project, maybe I should also put agriculture or agtech. Uh, yeah, it's becoming more professional now. And the roles that I have taken on before, I was working as an engineering lead, product owner, and a systems developer and as a systems developer at a startup in the Netherlands called Axerion. And there, uh, yeah, we were doing indoor localization, localization sensors for AGVs in the logistics sector, you might know. So I'm familiar with things like ROS, SLAM, visual SLAM, sensor fusion, navigation, calibration, 3D scanning. And
Shout out to our friends at Ross. I don't. Cat would not forgive me if I didn't give a little fist bump.
yeah, so yeah, these are the topics that I'm into. And luckily, these are things that I can also apply. So I can apply my professional knowledge and experience to these side projects, hobby projects, and vice versa. When I learn something, doing something with lasers, I can actually apply it to my work also. And I've seen that throughout my career, throughout my education. Yeah, like I said, currently I'm based in Berlin. I'm self-employed, providing engineering services and consultancy to partnering businesses, either on site or remotely. Um, and sorry, so the pictures on the right are special. Actually, I forgot to mention that first. So I mentioned that I have a farming background via my parents, and the first picture is a chicken that came near me when I was changing the hydraulic oil of our tractor, or it was spilling. I don't remember. Maybe it was like 10 years ago. And I was just working with a nut wrench, and this chicken just came out of nowhere, approached me, and with curiosity, just watched me very close by, and I was able to take a selfie, putting my arm around it. So, yeah, in a way that here we resemble each other. It was a
Love
curious
it.
human, yeah, like an animal being, trying to find out what's going on there, what this guy is doing. And I'm actually similar to that chicken in a way.
Very
So, and the
relatable.
other
Very
picture,
relatable.
yeah, yeah. Um, and the other picture is the iCup robot that I was fortunate to work in Italy with at the Italian Institute of Technology. And yeah, over the years, we are here right now. So the previous work, what I have done before about this topic. So this is the student house that I was living during my master's, and I just wanted to do something that year also. And I started with creating mock-up olives from clay because I needed something that looks quite like olives. I needed to paint them. I wanted to work on color sorting, and I had no idea how to do that. But I was familiar with the harvesting efforts every year. So my parents were going to our hometown and doing that. So I thought I could do something. And actually, I was thinking of mechanical solutions too, not just sorting. But I just made a start. And here I'm
Those are
brainstorming
what,
about,
like clay or uh,
yeah, clays that you can buy from hobby shops that hardens when you open the
yeah.
package, hardens over
I,
time.
I love paper prototyping, and so this is a whole next level clay prototyping. I love it.
Yeah, yeah, I quite enjoyed it also. I even put the pits, you can see. I'm not sure if you can see
Oh,
my
you
pointer.
went all out.
Yeah, it's only the painting is not good. So I'd never been a good painter, so you can see that the paint doesn't look realistic. But I would say the shapes are quite realistic.
Yeah, they're
Um,
believable.
yeah, and again, using a paper and some LED strips, made my own illumination unit here. Made a bit more sophisticated. All these I just bought maybe 5 meters of tape, LED, and just connected them together. I think I haven't soldered the ends yet here, but with a webcam and with this panel, I was looking at the olives now with a background also. And so during my bachelor study, I was familiar with Arduino IDE, and via Arduino IDE, I came across processing IDE. Right now, you can find many videos on YouTube about learning programming via processing, and it's a great way. You can just uh, animate things. You can interact with objects. I think it's quite a good platform. And on that processing IDE, I came across OpenCV. It had a library add-on for OpenCV for processing. And with
Processing is
that,
great, by the way. Just to butt in a little bit, I'm a big fan. I've built a bunch of little demos over the years, and it's one of those. Unlike a lot of these IDEs, it's actually focused on creative work versus the code side. Like it wants to
yeah,
just make it as simple as possible versus exposing every little tiny detail. And it's really great for just making interesting visual stuff and incorporating things like OpenCV and things like that. So big
yeah,
shout out to processing.
definitely, definitely. So I'm quite grateful to them also for introducing me to like the providing the platform to introduce me to OpenCV. And there, I think I found this project somewhere with like bars where you can play around with um, thresholding parameters, filters, uh, and blob detection here or contour detection. So I expanded upon that here. And with the olives, I was able to detect them and I was able to outline the colors of those, like color densities of those. So um, if you look at some examples here, I actually don't remember what's the first value, second value, third value. They should be RGB, but what's the fourth one? And which one is the fourth one? I cannot remember. But the idea was to get like a mean of the color and say, okay, this is pure green, this is slightly reddish, and this is black. By the way, I will come to that later actually, but why am I doing this? When you harvest olives, it's not always only green or it's not always only black. So the olives start as green and then they turn red and then they turn black. And it's not homogeneous throughout the fruit also. They start turning red, black from one side of the olive. That's why, although my painting is not really smooth here, it's not really an exaggeration that you can see really like two different colors on the olives during harvesting. And those are, yeah, they have to be selected. Again, cardboard prototyping, engineering. I made myself a light box here where I can throw an olive inside and view with a camera and really have powerful lights. This was like a modular design. And here on the right, I'm testing with different background colors and trying to see where I can get the best contrast to the clay
That's
olives.
This is
Yeah,
very interesting. Like you've built a couple of pieces of hardware here to sort of prototype that first LED box looked like a DIY project as
yeah,
well. This is
yeah,
very cool.
yeah. I like to just see things like with my hands and make things with my hands and see them. Really, I cannot really. Uh, yeah, I think it makes things iterations easier when you build like models and things like that.
Yeah, you got to get your hands
Um,
dirty. I love it.
Indeed, indeed. And on the right, the contrast test and the background color, which one is the best? It's done with RGB LEDs here. So it's sweeping through different colors and you can see which one looks the best and the worst. Because, like if you throw green light over a green object, it transmits, it reflects most of it. But some colors, uh, they how do you say that? They take in most of the light and they don't emit it
They
back.
absorb it.
Absorb, yeah. So I wanted to play around with that. And of course, these are not the real things, and we will see later how the actual like the fruits behave under real light. I haven't done this test on the real olives, but I'll show you. There was a good result with infrared light already, which I will show. Here I'm throwing an olive and I did my like the trigger mechanism here. I bought these floodlights from a supermarket and I took out the powerful LEDs with the heat sinks you can see and with an Arduino and like infrared. I think this is like a binary sensor that can be used like an end stop. So is there an object or not? It's used with um, like lighting units in your closets or things like that. So
Is it passive infrared like or does it use like a
yeah,
photoresistor or something?
I think infrared emitter and receiver.
Yeah.
infrared emitter and the receiver. So, and the idea was that I, I learned during this project that if I have more light, then my images are more sharper, and I can take pictures with a webcam of the olives when they're falling down, uh, even with a webcam without having a like a high-end expensive camera. And note that I'm a student here doing my master's, and yeah, I just increased the light, and I just wanted to throw the light in a short amount of time, in a powerful way. And here on the right, you see the prototype inside the shoebox. Uh, yeah, it's
Classy, very
I,
classy.
indeed. So I took it actually that season, that harvest season, to my hometown, but it yeah it wasn't. I couldn't do much with it. I wasn't prepared to change anything. Um, there was no like the internet and the heating, etc. You go basically on a garden, like a room without proper heating in the winter, and you have to be prepared with your tooling. You have to get your, I don't know, extra cables, extra connectors, uh, soldering iron and things like that. So I
There's so
couldn't do
many
much
things
with
that
it.
can go wrong in the field. It's basically
Indeed.
endless. You'll find something new to go wrong every time you do something like this.
Indeed, even like, and my hometown is an island, so you cannot get something easily. You cannot go out and find something easily. Also, it's a very small island with 2,500 people living there in the winter, but in the summer it's very crowded. So it's like a yeah yeah. It was, I couldn't do much then, and but what I learned during this previous work was I learned it was my first time using OpenCV. It was my first time learning about basic image processing filters, blow-up edge, color detection methods, creating a vision system using a high-end at the time a webcam. I remember like buying this. I think it was a Microsoft webcam, and it was quite good resolution and the frame rate. Um, yeah, and I was using like this custom illumination unit that I made myself. And inside the box, I made smaller versions of that. And then I've actually went to the floodlight units, but still they were hacked with the LEDs cut off and then using different drivers. Um, but I also learned that if you're not prepared to go on site with good hardware and software preparation, then yeah, there's not much to do. You cannot really develop things on site. You can develop beforehand and fine tune maybe, but yeah, on site at a farm, it's not always possible. So we fast forward to 2023. I thought about this topic in between, but I haven't really done something that is noteworthy. But this year I had some free time in November before I went to Turkey to help my parents with the olive harvesting. I wanted to prepare something. So uh, this is where we saw the post earlier. And the problem at hand was that these newly harvested olives, they go through a manual selection stage um, by hand, by human eye, and they are selected in two groups. Basically, it's a go for tabletop olive or no go, and no go ones go to the oil production. And the criteria are um, color, size, presence of any pest damages. It could be like fruit flies. It could be all the other bruises or other impurities. When you're harvesting them, maybe they got bruises or maybe hail damage and things like that. So you have to separate them. But it's quite it's something that relies on personal experience of the operator and their resilience. Like how long can they do that? It's um, you're looking at coin-sized objects sitting around the table, around the conveyor belt, and doing that over and over again. And after some time, you get tired. And when you are selling these to a corporation, they take random samples from your crates. They don't check everything, but they take random samples. And if they find one issue or a couple of issues in the sample that they grab, they can reject the whole lot and tell you to redo it. Go and come back later or next day. So that can
This is
be,
a very common issue with a lot of inspection and safety sort of things that humans currently do. Is that it's not that people are bad at this necessarily. It's just that over time in a given session, your eyes just sort
yeah,
of start to glaze over. Like you see the same thing over and over again for some hours. You can't be as accurate as you were at the beginning. It's just our eyes work that
indeed.
way, you know? Yeah.
Indeed, and it's hard to find people to for this. Like it's because everybody around that time, every grower is doing this, and you have to find the people beforehand. And my parents do it also themselves. Like they join. We have helpers, but they also do. When I went there, I also did it myself. And just over time, you get tired. You have to take breaks. But if you take breaks, then the olive sits there and it loses value too. So it can be lost. It can be uh, it can degrade over a couple of days. So you have to be quick to go to get them to production. They need to go into baths. They need to go into like this tabletop production with salt and stuff, or olive oil. So and my timeline and the budget. Prep time was like 2 weeks. I had recently finished a project in October, and yeah, it was the beginning of November. I gave myself 2 weeks, and after 2 weeks, I went to Turkey. I couldn't go too later because around December, mid-December, the olive harvest finishes. So normally it starts around maybe September, October, depending on what sort of olives you have, like green olives or black olives. Black olives are usually later, but I basically had like 2 weeks
Black
to
olives are
prepare
my
something.
personal favorite.
And mine too.
A must
Mine
on
too.
pizza. A must on pizza.
Ew. Okay. On site, I had like 8, 9 days, and I didn't have full availability uh, during those 8, 9 days also because I was really literally helping with different stages of the harvest. I was going on the field. Uh, you saw maybe from the pictures, they lay down these cloths underneath the trees. You have to, yeah, you have these fuel powered or battery powered machines that you can shake the branches. Yeah, so you have to use them. They're quite heavy. Uh, Sometimes you just need to climb the tree, and there are some spots that you cannot reach with the machines without damaging the tree. So you have to climb with the ladder. And carry the crates over and bring them to the factories and things like that. So it was limited amount of time on site also. And the budget directives were I wanted to keep it as low as possible because there is no end to how much you can spend otherwise, like with the cameras and other things that you can buy. And I wanted to achieve something small, but really achieve it, not to try to do something huge and then fail, because you have a window of opportunity that you can try these with real olives. Um, if possible, buy a rent instead of developing building from scratch. This is also to reduce the complexity. So okay, it might contradict with the budget, but actually developing and building something yourself from scratch can be more time consuming and can in the end be more costly.
Especially
Uh,
for a one person. You know, you can only do so much.
yeah, indeed. And when you're doing something new, if it's similar to something that you have done before as a like a single person or as a team, maybe you can take it on. But um, yeah,
The first
and
time is
use
always more difficult. It's the first time is always the hardest time. So
indeed,
it's how you can
indeed.
also a good way to track progress. You know, the next time you do it, you're like, I remember I had this issue before, and so you can get ahead of it. It's
Yeah,
yeah.
I love it. It's a very good thing. And use the existing equipment if possible. And what I mean by this is uh, you'll see in the coming pictures that there's already a table, a conveyor belt where the people do selection. So I didn't need to, I didn't want to think about yet another setup or mechanical table, something that is like a new thing to do that. I wanted to create an add-on on top of the existing equipment that's available. So the current state, there are two conveyor belts present. On the left side, two animations, they show the first stage. So the olives come from the field in a crate. They have uh, their leaves. They have all the like the mix, and this is the mechanical size sorting. So this is a huge long machine. I mean, like 4 meters, maybe 5 meters, and they have these elastic bands. And initially, it starts narrow, like these all 14, 15 belts. Um, they start narrow and gradually they open up. So the first crates that you see in the middle, the first crates on the right, because this one goes to the right and then from right to the left underneath, they get the smallest olives. And the last standing olives, like the last man standing, they are the biggest ones. So you have like this sorting. And usually you take like the most leftmost 5 crates for tabletop, and 5 right, they're too small, they go for olive oil without any sorting needed. But when you take the left 5 crates, so the big ones, you have to sort them because you see like the green ones, red ones, black ones, and they have impurities also, they have bruises. So you have to sort them. That's where you go to the second conveyor belt, where people can sit around. It has lighting over top, and you take in olives, you start the machine, you bring it to a stop, you sort them. Bad ones or the good ones go in the middle, depending on which is the majority you can choose, and they are separated basically. So right, left are the same group. If they are standing, they're good. But the middle one is going into a different crate, which is rejected. So the
How many,
approach,
if I can
yeah,
butt in for a minute, like how many
yeah.
tons or how many olives does the family go through in one harvest? Your specific.
Oof, tons wise, I should have. Yeah, I think we have around more than 600 trees, and tons wise, maybe between 5 and 10,
Wow,
something like that.
that's
It's
that is a lot of olives.
yeah, it's quite a lot. Yeah, I mean, still it's a small scale production, but you cannot do it just like by yourself or
Yeah.
just family. You need to get help. Like
Mm.
there are people here during the day. There are 4 or 5 people working outside, and 4 or 5 people working inside at the end, like in the evening. That's why we have the lights on. It looks dark here because
Yeah,
you're in the field during the day and you're inside during the evening. And
makes
you
sense.
eat there, you drink there. It's like your whole time you spend at the field.
And that's for like 8 or 9 days. You said is the normal kind of duration for the harvest there.
No, that's the time that I gave myself. I didn't
Oh,
want
I
to
see.
make it too long. And actually, I thought based on you see the amount of olives on the trees beforehand, and I checked with them and they said maybe we can finish within 2 weeks. So but I didn't want to stay for too long. I wanted to uh, yeah, 8 9 days I gave myself, but
Got it.
I didn't have longer time. And actually one week after I left, they finished. And here also the rain plays a role. So when it's raining, you cannot go on the field. It's too muddy. So the all the cloths on the floor, on the ground, they get muddy. So you don't harvest when it's raining. So we had some days when it was raining too. So you can get interruptions like that. You cannot always work, unfortunately. Um, so the approach that I wanted to take with this conveyor belt and like the problem at hand, I wanted to build an add-on for the existing conveyor belt. I will speed up right now because we don't have. I'm
Uh,
going a bit
take your
slow
take
now.
your take your time, man. It's all good.
Okay, all right. So I wanted to create an add-on for the visual sorting part, and I wanted to use a camera to detect the olives on the belt and analyze them for sorting. Are they good or are they bad? So you can see with this camera that's looking down, and the olives are coming from the left to the right. And I wanted to show the results from the selection to an operator directly on the belt on the olives. I actually wanted to, I thought about using a projector at first. So the projector sees a wider range of the belt because a human can reach with two arms and there are actually more like multiple people there. So you can use a longer range, but you can actually do the selection with a very narrow field of view camera because the belt is not so wide. So why do the detection throughout the whole thing? Just even with like a line camera, you can do the selection at the start and then later you can just show, okay. But for that synchronization, you also need a second camera that can have a wide field of view. I thought, okay, like you can mark this, you know the speed of the belt, or you can measure it by the moving olives, and you can actually track, okay, this is a good one, this is a bad one. You need a calibration step at first, and then the whole thing doesn't move. So it can work. Um, and after you make the selection and you decide, okay, this is a good one, bad one, project something, a color over the olives, and just the person picks them up easily without having to look. So they're not they can work without thinking so much, without using their eyes or without trying to, focus on a part or looking at details, picking them up. Um, so this is the initial idea that I had, and yeah, it was a double camera projection thing. Maybe it can be the
It's
future. Yeah.
it's really important for folks too. I love seeing the bit of the thought process and your planning, and the scope earlier. With the give yourself a timeline, and this stuff is all really important because these to do this stuff up front, because it cuts out so much time when you're actually building if you've really thought things through. Like, yeah, you can just start, but it's going to be a lot slower of a process unless you spend some time writing things down, drawing pictures, and really scoping it out. And it's really impressive to see the thought process here.
Yeah. Thanks a lot. Because when you create something that's not reasonable, then you can get demotivated with the project earlier on if you don't foresee like type of things. So yeah, you need to grab a bite that you can really grab. It shouldn't be minimalistic. You shouldn't be very cautious, conservative, but at the same time, you shouldn't be very ambitious. Otherwise, you'll just fail
But and it's
because of your
important to
planning.
keep yourself it's important to keep yourself interested too. Like you're not just managing the project, but kind of your own enthusiasm with stuff like this.
Yep, indeed. Don't cause yourself burnout or yeah, despair
Yeah, definitely.
with something that you love. So yeah, this was the initial idea and the method of projection. So here we come to the lasers, the fun part.
Hell
Um,
yeah.
So I actually came across these galvanometer laser scanners before. You probably have seen them too. If you're like me, following like pages on Instagram or YouTube, the algorithms, all these nice algorithms bring all these DIY stuff and fast working lasers, clearing the rust out of materials or engraving stuff on leather or metal things.
Yeah,
So
with all that
I
that
knew
ASMR audio of the kind of noises. People love that.
exactly. Exactly. It's just, yeah, like it's, you get focused on it immediately. And I knew about galvanometers, but I never got my hands on one. And I checked those engravers actually. If they were cheap, I could buy myself one because I did in the past an engraver, like a 3D printer engraver, CNC thing. Another unfinished project, but I was able to engrave with laser. So if I could get my hands on one, I could also use that, but I couldn't have the chance. So that's actually one part that, yeah. So I chose this based on the following criteria, and the fourth one you see, I haven't worked with it yet, is a big criteria because I want to use it and I want to learn how. Yeah, I just want to experiment with it. But the other thing is the projectors. There are like LCD projectors, LED projectors, DLP. Some LEDs are like similar to DLPs using DMD chips or not, but something powerful that can show uh, stuff on that belt. Also combined with the illumination coming from the ambient light and the overhead lighting, it has to be powerful. So I bought actually at the beginning of this project, I bought cheap small projectors. I thought maybe if it's small, but if it's powerful, if it's visible, then I can use it. But they weren't sufficient in power. So and I didn't want to invest in a big projector. That yeah, I
They can be
just didn't want to do
expensive.
that. Yeah, they are quite expensive. They can be a good investment, but I don't know. When there was this alternative of galvanometer based laser projectors, which I came across, it yeah, I just wanted to work with those. I just wanted to try those because I knew I expected that it would be fun to work with them. So uh, and then there are two options. You can buy one and hack it, or you can make one. Uh, I'm not doing something with like laser engraving burning, so it should be something safe, relatively safe. It should be about visibility. It shouldn't be about changing something on the object that you're uh, projecting to. And here is actually a newer one that I have. This is like 4 mirrors, 4 different lasers, and these are widely used for light shows and things like that. So in the next slide, actually you can see the stuff that you can buy that if you want to make your own with 2 galvo mirrors here, these 2 motors and the motor driver and the power and the cables. You can buy this, or you can actually so the same thing, almost the same thing is inside this box. Plus it comes with like all these pre-programmed patterns. You don't have to create these on your own, and
Very
it's in a
cool.
box, and it's coming with 3 lasers. Here there's no laser, and the price difference was really small. So then
About how much is the Amazon model here?
this is 110 euros.
Okay, yeah, that's not bad at all.
If somebody wants, I can send an affiliate link
Yeah,
that
no,
we can
sure.
all.
Get yourself paid. Share that Amazon promo code thing. Yeah.
No, I'm just kidding. But yeah, you just go ahead. It's quite simple. And actually, I have a few laying around because then I checked like the other shops, like Temu, for example, and they have even cheaper ones. But they are slower. There are differences in the galvos, and they don't document. And I should note one thing: it's really hard to find documentation about these things, like how fast you can move, what's the input ranges, like is there a communication protocol? They're not well documented,
That's
or
often the
I
case
wasn't
with
able to
these.
find.
Yeah, it's often the
Yeah,
case with these affordable, just simple box stuff that you'll find on like Ali, Express and
yeah,
things, or Amazon.
yeah.
Usually, if you plug them in, they pretty much work. But if you need to know something, it's often difficult to find the information you need.
So it's a good challenge for like a weekend project to find out how it works and yeah, do something with them. So I got this one, and first of all, the preparation. I disassembled the unit. I looked into the system components. I knew about like galvo scanners via videos, but I didn't really see one firsthand. And eventually, I also wanted to just remove the all the peripherals PCBs that are not needed because I might have to do some modification on the PCB. Um, I don't know, solder wires or things like that. In the end, I didn't have to do so much, but yeah, this is how I started. And here you see like a system breakdown. Um, on the top, you actually see these black stuff are three LEDs, LED laser diodes, and this is a beam combiner. So there's like red, green, blue laser diodes, and these reflector films are reflecting certain wavelengths. So this is how you are combining a single point, three beams into a single beam. This is how they do that. So there's no single RGB LED. There are three different RGB LEDs, but this is a beam combiner that's used here.
And that it's
So,
very
so
precise in order to get those to line up too. It's interesting.
yeah, indeed. And the assembly wasn't precise. Like there were some glues, and it didn't look really sophisticated because in my past, I worked with optical equipment. I actually we had a product that has optical components, and I worked with glues for gluing optical elements together and lens elements and things like that. So I was surprised by this, how it works, but it just works. So uh, yeah, these are like plastic casings for the LED diodes that they have, like plastic injection molded casing. If I were to do something like that, I would go with CNC machining, for example, to place the LEDs. But yeah, it also works apparently. Yeah, of course, it depends on your requirements too. If you look closely to the end beam, when you switch the colors, when the position point is stationary, you can probably see that it's maybe slightly offset, but it's sufficient for the light show apparently. Uh, so the main board is main board, microcontroller, memory keeping the like the program and pre-programmed patterns, inputs for the microphone. So you can actually use this device to listen to music and just it um
It's cool that it has
changes
DMX.
the
Yeah.
yeah. Yeah, and it has DMX. This is a whole new world to me. I haven't used it, but it can be exciting that you can, yeah, so, like from your music equipment to this. I guess you know more about this field, right?
It's pretty so DMX this is a it's a standard and it's really common in like concerts and live venue and events and things like that.
Yeah.
It's super widely used, but not I would say not very well loved. I think a lot I've known a few people that like run shows at some of the nightclubs here in town, like DNA Lounge, for example, and they're always complaining
Mm.
about something with DMX, but it's what everybody uses. So
Yeah, yeah. Actually, I thought about getting a like a hat, a shield for Arduino, which has a DMX output, so that I can control this. Maybe it's possible to do that. You can control the device, maybe even the color and the exact position of the beam.
very
But
cool.
then I figured out something up here that like the main board and the motor driver, the dual galvanometer driver here are separate, and it just works with an analog signal. Then I just went with an easier solution. And the bottom one is a power management PCB, and the two galvos are here. And I will show a front picture later. I will show you the mirrors later. So I figured out that one connector provides the analog signals for the mirror positions, and I started listening to the signal. Looking at the demo program, it's doing patterns after patterns sequentially, and I looked at the signals. What's the range? It's minus 20, minus 12, plus 12 uh, range, and it's just I looked at the frequency, like how fast it's supplying the signal. So I investigated how it works, listened to with my oscilloscope. Um, and here, actually, yeah, this is the first time that I actually created a sine wave. So after looking at the signals, okay, if it takes in 12 volts, minus 12 plus 12, I can actually send it 0 to 5. So I'm using a smaller range of the X and Y mirrors. It's actually, since it's like half of both and it's like a quarter of the field of view of the projector that I'm using. And I used a digital to analog converter here. So from Adafruit, you have uh, with Arduino. I'm not sure you can do that. Maybe with Leonardo version you can, but with Uno, I'm not sure. But I knew that I would need this, so it's a like 4-channel output, and with also different voltages, it would be necessary. So here I'm sending a I squared C m- signal or message to this board, and it's setting the voltage here. Of course, it's at first very slow, it's not clearly visible, but this is how it started. So the first step. And then later, I started programming the patterns on the Arduino. Okay, a pattern to draw a square, a pattern to
Bounding
draw,
box. Yeah.
yeah, and though like this circle, triangle. And these are objects with certain properties, size, and position. And okay, so then slowly I added, okay, show me multiple boxes now, show me multiple squares. Then let's make them bounce from the walls and move. This is actually very similar to what I initially did back in the day with processing ID, programming these patterns to move around and bounce and things like that. And here you can see uh, it is showing the trace because the laser diode is on. It's the device is thinking that it's doing the demo show, but uh, yeah, I'm governing the motors here, where while it's using its own laser sequence, and it's always on or yeah, sometimes shutting in between. So here it's the front part, and when I was trying to control the laser diodes, I actually burned two of them. They're very they're not protected here on the diode part, but on the PCB with some resistors. And the diodes are quite a hassle. I'm not an electrical engineer, and yeah, I should have known about this before. But yeah, without proper protection, you have to limit the current. You cannot work with voltage. And I thought I had enough resistance, but when I was trying to push the limits, I burned two of them. Then I switched. I had a nice laser diode which I had
I
worked with
mean, you
before.
know, if you're building something with lasers and you don't burn out at least a couple of them, are you really trying? I don't
Yeah,
know.
indeed. Thanks. So I just changed the one with something that I had and something that I had used before, and it actually worked fine. So I didn't even remove the beam combiners, so I just replaced the red one with the red one that I had. Uh, so this is like the assembly. We have an NVIDIA Jetson Nano 4 GB with a metal housing. We have Adafruit digital to analog converter. We have one DC. Actually, it's a motor driver, but you can use it to run the red laser diode with internal resistor. Uh, it's based on PWM. No, actually, no, this is just on off. This is just on off because I'm not using an PWM output. It's high or low from the Jetson Nano, and then the motor driver just runs it. And the modified laser projector, which just allows for the two mirror positions. So these cables, in the end, you will see the interface and one laser diode on-off power signal. I have one camera from IDS Imaging Development Systems uh, in here, and it's quite a nice camera with USB 3 interface. Not a webcam anymore, working with real machine vision stuff. And yeah, design and printed parts. So I do also 3D design, 3D printing myself. And I just made everything. I don't wanted to connect everything together, not with
Mhm.
duct tape or double-sided tapes, but with mounts. So in the back, you see actually the ground cable and the two signals for the mirrors and ground and the power for the laser.
Some really
And
nice
that's it.
casing here as well.
Which one? The
It
top
just
or the
the
bottom?
way it comes together is pretty nice. It looks is the top one
Oh yeah.
DIY? Did you make that one?
No, this is I bought it. It's like a
Okay,
housing for Jetson Nano.
cool.
Eh, yeah.
I see your
But
3D printed
it's quite nice.
adapters. Yeah, your 3D printed kind of mounting adapters there are nice as well.
Yep. Yep. Thanks. So I actually used also the existing through hole, so it's keeping the cover and the mount also together. Um, and yeah, finally image processing. So we come about the OpenCV part. So what do we have to do? We have to detect the olives in the images. We have to analyze the detected olives based on some criteria that we discussed earlier, like color, bruises, and things like that. And we have to convert the olive positions from the camera images to the projector coordinate frame. So you have an image, for example, and you have an olive on the top left corner of your image. And the projector's frame is somewhere different. They have overlap, but they can be slightly distorted or warped. So you have to have this transformation between the two. Um, First, the detection part. So the detection of the olives is actually not a very difficult problem here because we have a controlled environment. The olives are moving on a plane. The belt is like white colored. There is no texture behind, and you have illumination. You can provide extra illumination if you want. Uh, the olives are moving steadily over the thing. They're not rolling around or changing speed or bumping, hitting each other. And the olives are also they have a certain shape that is like an ellipse or like similar to a circle, and they have a smooth curvature. So they're clear like blobs that you can detect easily. But we have to tune our parameters correctly with blob detection. And here on the left side, you see the parameter set for the blob detection, simple blob detection from OpenCV. This is maybe like the first things that you do with OpenCV tutorials, like blob detection on images. And with these type of objects, this background, it's actually quite simple. So you can, and you have all these nice criteria that you can parameterize and tune your thing for. So you don't want to make it a perfect circle because the olives are a bit elliptic. On the right, I'm using fake olives. So before I went on site, I bought like fake olives, decorative stuff, like grapes, fake grapes, decorative stuff. So they look circular, but when I went on site, they were a bit elliptic. And this is the start. So I'm detecting, and I'm not shutting off the laser. And here I'm just pointing a point to the olives, and you see the blob detection working and not working. It looks like a fire show also. Uh, so, and I talked about illumination and light reflectance, etc. So, uh, actually, I should have shared this later, but these olives are under infrared light. And under infrared light, actually, you see much more than what you can see with the eye. So I wanted to combine visible light with infrared light to create contrast with the background and to see the details of the olives. We have a colored camera, so we can split the channels of RGB and look into different channel images and decide on the best one to detect the blobs. And then after you detect the blobs, you are not done. You have to detect the contour of the olives. You have to be really specific on where these things are, because these black spots that you see, they're bad regions. They are old. They are dead. They have maybe they have like fungal stuff, and they have like these small dents. They are fruit flies, olive like worm entries and things like that. So the tissue, the living tissue of olives, they show the bruises under infrared light, and I think it's quite applicable to many other plants also. Um,
Really
that's why
interesting.
hyper. Yeah, yeah, go ahead.
I was just saying it's a very interesting, and
Okay.
it makes sense. Like a lot of organic materials have this where uh, you'll be able to see things under certain types of light that you can't see just with our eyes.
Yeah, that's why hyperspectral imaging for with the drones, they are used for monitoring of crops, etc. It's a
Yeah,
huge field, and yeah, quite
many
fascinating
things
also
can
to.
hide beneath the skin of fruits and vegetables.
Yeah, and we analyze each blob. Uh, we first define what to look for: surface roughness, color changes above a certain threshold, mean color. So these are the ideas that I had. You can add more stuff here. You can have many different features, but yeah, on site I could only check for color and the changes over the surface, like the sudden changes. So if it's not very smooth, then it's a bad thing. So it's detecting bruises basically, and display the resulting selections with the analysis. So here you see one result, like here to come to this, to come to the blue result where we really detect the olive. Uh, we split the image channels, we apply Gaussian blur, we apply adaptive thresholding, finding contours on the blob mask. So each blob we take like a patch, and in this patch we find the olives, and then calculating the histogram inside the olives, looking at every pixel value. And you can also see that there are some reflective regions too. So we are not interested about the bright spots, bright variations. We are interested in the dark spots. Because if you only look at the change, positive change or negative change, you can falsely say that this is a bruise, but we are actually looking for the black ones. So uh, yeah, so this is like these are like the steps to follow. And of course, when you have a sophisticated camera, you can also change the camera settings. You can play around with the many modes and see yourself what works best. Here, I think there's both. So definitely there's infrared light, but there's also visible light. And with the visible light and infrared light, you get different color contrasts and see what works best for you. And since the environment and the fruits don't change much, you can just stick to the settings, um, and you're good to go. About the perspective calibration of the camera and the projector, I just actually created a simple four click transformation, so 4-click routine to find the transformation, because there was low distortion both on the camera and the projector. So I noticed that if I just say on the camera and project like a square on the projector, okay, like projecting a frame around the thing, showing the field of view of the projector on the camera, and if I can just select the corners, then I can align both of them, and this worked quite well actually. So I just click 4 corners that I see on the image, and then boom, it just they're aligned. I don't have to do much distortion on distortion, because the lens that I use does not have much distortion, so the straight lines are quite straight. I just have a warp transformation between the two systems. If you have like a fisheye lens or a system where either one of them have quite a distortion, then you have to uh,
You'd have to
you have
run
to calibrate.
undistort. Yeah.
Yeah, you have to calibrate your camera and the projector. There are methods to do both with some like calibration patterns that you might easily find. You can print and you can undistort, and then you can apply this same thing. And the software, very quickly, we have multiple function blocks. So image acquisition, pre-processing, olive blob detection, analysis of the olive blobs, and projection of the results via the laser projector. So this one uses I2C communication, the driver that I wrote on top of the other Adafruit driver to use it as a projector to say, okay, now give me these many squares in these locations and things like that. So I get one frame n in this thread, and then the other thread is actually working on the previous frame, and the other thread is actually working on 2 previous frames. So you can parallelize multiple things with like sequential work, and you can actually run as fast as your slowest process. So I'm limited by the slowest single thing here, but I'm not doing them sequentially. So if I do them sequentially, it will be the sum of them that my frame rate is affected by. But it's already parallelized that you can do um, uh, you can utilize your CPU, GPU more basically. So this is before I was ready to go on site here with these simple grape stuff. We are doing the color detection. This is on-site investigations. Here I have my Turkish coffee, or for the Greek audience, it's Greek coffee. That was by my side, and yeah, with the projector. And here the difference between visible light and infrared light, you can see. This is how it looks. So you cannot separate the green and red and black, but you can actually separate for the bruises and impurities. So yeah, that gave me an idea which I will discuss in the future work part. But maybe we can work with visible light and infrared light at the same time if we can synchronize the illumination units together and trigger them at separate
Yeah,
times. So one frame colored, one frame infrared. So it can work. This another image. You can see, especially here, for example, that's underneath the black olive. It's hard to see by eye or by this camera image, but here you see the issue. Of course, another thing to work for is the pits. Like the pits they look like impurities too. How do you detect a pit? And that's a good challenge for next year maybe, and where machine learning can come into play to separate the pit from actual bruises, training on real data. And yeah, this is like the on-site test. You can see the obviously very bad ones that are separated. So the future work, you can see here that not olive is touching another olive, because current detection algorithm doesn't work when the 2 blobs are touching each other. It can be solved, but it's not yet solved. So it's something to solve so that you're not constraint to separate the olives. That can be quite complicated, and they're touching, but they're not on top of each other. So you should just allow the system, make the system be able to separate the blobs even when they are adjacent to each other. Synchronize the illumination units with camera. Right now, there's like a floodlight infrared that's running always, and the visible light, but you can synchronize them because the trigger input and output of the camera can be utilized, and you can have nice system with less power usage, and that's very accurate in timing. And you basically don't throw out unnecessary light, and you know when to expect the the wavelength that you want. Enlarge the field of view of the projector. I discussed about this. So right now it's using 0 to 5 volts. But if you have 24 volts with a voltage divider, you can actually use this. Maybe I can amplify this signal 0 to 5 with an amplifier and divide them into two, so I can use the longer range of the system if I keep using this projector. Make the projector unit more compact. So I don't use the main board right now, although I can convert the projector back to the original state and I can use it for partying. But if I want to sacrifice it, I can just use the driver and the galvo units, make something much more compact, or buy the units like from eBay or wherever I can find, just to make my own. Investigate what type of conveyor belt material would perform best. I think something that can create more contrast would be nice, because under the light you see the underneath is white and the olives are also grayish. Something more darker can work better. Blue is not really present on the olive, so blue, something on the range of blue can also work. Find a solution for the dark side of the moon. Do you have a guess what this is, Phil?
Being a Pink Floyd fan, my answer is money.
Yeah, this is for the dark side of the moon is the behind the olives.
Right.
So
We can't see through them.
we can
So we
see
don't.
through them. We cannot see behind them. So and yeah, it would be a money problem too, because this as it is right now, it's only selecting from one side, and you can easily do false positive. So underneath there can be a bruise, but on the top there's nothing. So yeah, and this is a big problem that you ignore underneath the olives. So you have to find a solution for that. You have to turn the olives the right amount of angles, something mechanically, or you have to think about changing the conveyor belt completely and do something else. But this is for it to become commercial. This is something important. That yeah, you have to find a solution for that, and get ready for data collection with the hardware setup and software routines. This time I wasn't able to get a lot of data, although people were already sorting manually. There was huge potential for good amount of data that's already based on sorted olives, but I wasn't able to prepare something to use for data collection. And next time I want to do that, so that I can create a database of olives, good ones, bad ones, just the olives, not just full pictures, full frames that I will have to post-process later, but I just want to like a dictionary of olives basically. And it's possible because we just need to provide the system for it. People are already separating, and they will be separating them. And again, this system is like to be in a collaborative system with people. So people will never be out of the picture here. And fine tune a pre-trained model based on selection criteria provided by the operators on site on real fresh data. Like I said, they are training, they are sorting already, and it would be nice if they can say they can provide some outliers if they come up, and then they can provide it to the system, and they show, okay, this is a good one or this is a bad one. This is a corner case. Use it on your system too. And for this, I would have to also move into machine learning and really go there with a pre-trained model and maybe train it further on site based on the available data, iterate. yeah, this is
I'm sure
something
that
that
I'm sure that our friends at RoboFlow would be happy to see you try out their platform for this project.
yeah, actually I saw them. I came across them on LinkedIn multiple times, but unfortunately I couldn't have a chance to try it yet. But it's on my list to
The free
try out
plan is
their
very
platform.
generous. Give it a shot.
Okay, cool. If they come into contact with me, yeah, it will be nice. I just need to find the time and but they're on my radar, definitely.
All right.
Uh, so yeah, we can find more things to do, but this was the list for now. And yeah, thank you for this opportunity. This is my LinkedIn profile. You can take a picture and see if you want to send a message or connect. Uh, you can reach me. And yeah, thank you, Phil, for inviting me. This is yeah, quite special, and I hope you enjoyed it.
I certainly enjoyed it. Thank you so much for the awesome presentation. Loved seeing your thought process and just kind of start to finish how this project came together. Very interesting. Um,
Thank you.
go ahead and unshare your screen here, and we'll do our trivia giveaway here. So, howdy, folks. Thanks for sticking with us. We went a little bit over time, but I think it was totally worth it, and not many of you dropped off. Episode of OpenCV is a giveaway to you in the audience. I am going to ask you a trivia question based on the presentation from our esteemed guest. This one is going to be a two-parter. If you have won in the last couple of months, please do not answer and give other people a chance to win. The first person to answer correctly in the Zoom chat will win the OpenCV course of their choosing. You can go to opencv.org to see what courses are available. Get ready to answer. So we talk a lot about OpenCV being a global community, and I think this episode is a great example of that. So I'm going to ask you this question. Where is our guest Talha from? What country? And where does Talha live now? What country? Two countries. Ooh, I'm gonna have to say Jordan got this one, even though Jordan was a little bit overly specific. The answers we were looking for were Turkey and Germany. So congratulations to Jordan who got this one. Jordan, please send one email to phil@opencv.org and we will make sure you get the course you want. Take a look at the courses before you email me and just tell us which one you want. And the OpenCV courses support team will make sure that you get it. Thanks so much to the team out there for being on top of this stuff. Um, we've got a couple of questions, but I think we're a little bit over time. I'm just going to ask you one here from that a couple of people have asked here on the during the live stream, which is what while building this project, what
Mhm.
surprised you the most?
Um, yeah, the actually it's not related to the project, but the amount of effort that goes into the amount of labor that goes into this production of the olives that we eat and drink, put on our salads, it's quite a lot. And yeah, I really appreciated that. I knew about that before, but every year I either had school or like work or something like that. I never joined the harvest for this amount of time, and that surprised me actually. And then to have the potential of doing something for this, making uh, people's lives easier, uh, it pr it proved more valuable. That's
That's
the part
that's
that I
really
found.
important, and I think with a lot of these projects, this is true of many machine learning, computer vision tasks, where excuse me. Ooh, man, that one got up on top of me. It's really important because to get your feet on the ground and like get some one-on-one personal relationship with the task you're trying to solve, because it's easy to miss things that would be obvious to someone. Your family is involved in this, you didn't really have that one-to-one direct experience, and getting it made this project, better for you, made it easier to work on, or maybe it just gave you a deeper understanding of the actual problem domain. And that is so important for these projects. So It's really
Yeah,
great to
indeed.
hear that.
I think also professionally, it's like the same thing. When you're doing a product for a customer, you have to really get into their shoes and you have to really go there
Yes.
and observe what they're doing. And you can spot other things that you can improve, that you can actually add value in the different parts. So you have to really be present and you have to really observe and see and yeah, get your hands dirty if possible.
Yeah. And it's true with any of these kinds of projects that we use these highly advanced algorithms and custom made hardware and really powerful devices like the Jetson and all these things. But in the end, it all really just comes back down to people, like being there and knowing what the problems are. You got to talk to people to get that. And I think it's really important to remember that. And this is a great example of that in action. So yeah,
Yeah,
thanks so much,
thanks.
Tala. If people
You broke out for me
sorry about that.
for a while, Phil.
If people want to find you on the internet, where can they find you to follow the project?
So I have my yeah company page actually Arioviz on LinkedIn, and I saw somebody post ask the question, can you share the link?
Yeah,
So
is
I will
there a
share the
GitHub
link now.
repository or
To follow the project? No, not yet. I might do something separate for the driver part, for the projector controlling the Galvo scanner with the Adafruit thingy, and for the image processing part. But I want to, yeah, right now, like I was working in a rush, so it's like a spaghetti right now. Although I was able to parallelize things and make it work, I need to document and I need to separate things. So, for example, working online and offline, working on a video and on a live stream. Uh, Right now, it just works with a single camera, single projector, and maybe after those separations, I can share like a demo version on GitLab or somewhere.
that would be great.
And for that, you can follow my page on LinkedIn, Ariovis. I'll share a link to that one too. Or personally, of course, you can follow me too, but I will share from Ariovis further.
Great. Really appreciate that. Before we get out of here, we've got a couple of things I want to bring up OpenCV wise. The OpenCV Indiegogo campaign has ended. We ended with just under 200,000 raised, which is significantly less than the 500 we wanted to raise, but still a respectable number, especially because we were just raising money for an open source project. We weren't selling anything, and so um, we'll be talking more about OpenCV fundraising in the new year as we solidify some more plans. So stay tuned for that. They may involve this handsome T-shirt that I'm wearing right now. Yeah, I'm OpenCV. And if you love OpenCV, stay tuned for how to get one of these shirts. We also just ended OpenCV AI Competition 2023's grand prize judging, and we announced the winners last week. That was a really fun episode and got a lot of good attention out there for folks. You can go to the Hackster competition page to see everyone that won. But importantly, right now, we've got the community voting period, which means that you can go and vote for your top 3 favorite projects to win them some more prizes from our sponsors at Seed Studio. You can find the link to that by going to the Hackster project page or going to opencv.org. With that said, there's another episode in the books. Thanks so much, everybody, for watching us here. I know my internet connection was a little bit unstable, so I might have dropped out a bit. I'll try to fix it in editing. Thanks for watching. Thanks for watching every week. We'll be back next week with another interesting presentation from someone in this very interesting industry. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be.